Okay, welcome back to COIC 2325. This is Chapter 7, Integer Arithmetic. This is Part 1. So in this chapter, we're introduced to the 86 binary shift and rotation instructions. So these are we're going to be learning a lot of new instructions on how to shift and manipulate bits with the ones and zeros. This is a really powerful tool that assembly language has, which is something that's needed when we work with computer graphics, data encryption, and hardware manipulation. In this video, we're going to cover the very first topic here in the bullets, which is shift and rotate instructions. There are many of those, and I want to make sure that you understand exactly how they work. So we're going to look at some examples and work them out together. So we're going to look at, hold on one second, let me grab the pointer. There we go. So we're looking at logical versus arithmetic shifts. The shift left instruction, shift right, shift arithmetic left, and shift arithmetic right instructions. The roll instruction, so we're rolling to the left and right. And RCL and RCR instructions, and SHLD, which is shifting left destination and shifting right destination instructions. All right, so let's look at the logical shift. So a logical shift fills the newly created bit position with 0 and copies the bit that gets moved out to the carry flag. So anytime we do a logical shift, whether it's to the right or the left, so here we're doing it to the right, the bit that's right here, which is the least significant bit, it's going to be moved to the carry flag, and this space that gets created here, this bit space, will contain a 0. So 0 will be copied in this place. If we have an arithmetic shift, what happens is, for example, here we're looking at an arithmetic shift to the right. If we're just shifting 1, we shift this bit to the control flag, and then the very last bit that we had here gets copied. So the most significant bit here is a 1. So this 1 gets copied to the open position. So here's a shift left instruction. The shift left instruction performs a logical shift on the destination operand. So we have SHL. The destination operand can be a register, it can be a memory, and the second value that we have here is going to be the number that we're going to shift. So we can have an immediate value like just a number 1 or a number 2, which is we're shifting 2 bits to the left, or we can have the CL register with that number that we're shifting. So if we have the CL register contains a 2, that means we're shifting to the left 2. So in this example, we're doing a shift right here to the left. This bit, which is the leftmost bit is going to be copied to the carried flag, and then we fill this bit here at the end with a 0. Most significant bit, that was the word that I was trying to get to. But it is the leftmost bit also, rightmost bit. Okay, so here's an SHL example. So we move this binary number into AL, and here we're going to shift the bits in AL by 1 position because there's a 1 right here. So let me now grab a pencil. Yeah, here we go. Good, right. Okay, so here, if we're moving to the left, we're going, so we have 1, 0, 0, 1, 0, 1, 0, 1. So we move to the left, so our carry flag is going to be set to a 1 because this is the bit that gets moved to the carry flag. It's going to be the most significant bit. So our new number is going to start here, and we're going to fill this with a 0 here at the end. So our new number is going to be 0, 0, 0, 1, 0, 1, 0, 1, 0. So AL actually, that register gets updated with the new number. Here at the bottom, we're looking at an example using the CL register. So all we did was use the same number, the same binary number, moved it into AL, and then moved 1 into CL, and then just used CL in the SHL instruction. Same thing, but just using the CL register. So shifting to the left 1 bit allows us to do fast multiplication. Grab the pencil again. Okay, so shifting left 1 bit multiplies a number by 2. So let's take a look at why that happens. So if you remember, when we have a binary number, so this is position 0, 1, 2, 3, 4, 5. Actually, I think I have a slide for this. So let me show you that slide. Yep, I made up a slide to make this easier. So here is, here are the positions. So this is position 0. This is 1. So right, so this is where our binary number would be. 4, 5. So this is 1 byte, which contains 8 bits, right? Okay, so if we have, let's say for example, a 1 here, a 0 here, and we'll make all these zeros here. Then shifting this, so if this is a 1, we know that this position is worth 1, because you do 2 to the 0, 2 to the 0 is 1, that equals to 1, 2 to the 0, and then you multiply it times this 1 here, that gives you a 1. Well, if you shift this 1 here, and you make this a 1, and this is now a 0, so this is 0 and this is 1, then you have 2 to the first power, which is 2. 2 times 1 is 2. So it multiplied the 1 times 2. If you shift the 1 to here, and this is 0, then you have 2 to the second power, which is 4, and 4 times the 1 gives you 4. So by shifting to the left 1, you are doubling the number. So let's look at an example of a number. So let's say that I have a 1 here and a 1 here, and the rest are zeros. Okay, all these are zeros. All those are zeros. So this number is, this position is worth 1, this position is worth 2, this one's worth 4, 8, 16, 32, 64, 28. So all I have to do is add the 1 plus the 4. And this binary number of all 0, 0, 1, 0, 1, this binary number is a 5 in a decimal number. Because this is worth, this one is worth 1, and this position is worth 4. So 4 plus 1 is 5. Now, if I shift, so this becomes a 1, and this is 0 stays a 0, or becomes a 0, and I shift the second bit to the third one, and it, now this is a 1 and this is a 0. So now I have 2, so this is worth 2, and position 3, bit 3 is worth 8, so 8 plus 2 is 10. So by shifting 1 to the left, I have taken my 5 and doubled it, or multiplied it times 2. So anytime you shift to the left, you're doing a fast multiplication, you're doubling your number. So try that. Try shifting 1, 1, 0, 1 to the left 1 time. So this is worth 1. Shift, this is worth 2, but we're not going to use the 2, we're going to use the 4. And this is worth 8, this position. So 8 plus 4 is 12, plus 1 is 13. So this binary number is equal to 13 in decimal. And now if I shift the bits left 1, I'm going to have, let me erase this down here. So I'm going to shift my 1, 1, 0, 1 to the left. So I'm going to have 1, 1, 0, 1. And then these are zeros over here, right? So this is worth 1, this is worth 2, 4, 8, 16. So 8 plus 2 is 10, plus 16 is 26. And that's it, because I'm not using the 1. I was like, wait a minute, got 27. Okay, so I'm not using the 1 because bit 0 is 0. So I have 2 plus 8 plus 16, which is the double of, is 13 times 2, which is 26. Okay, so try some of those by yourself and make sure you understand how to do that math. Okay, shift right instruction is fast division. So we're going to shift to the right, and the rightmost bit, or the least significant bit, is going to be our carry flag. So if there's a 1 in bit 0, then carry flag will be set to 1. If there's a 0 in bit 0 here, then there'll be 0 in carry flag. And then we're just going to add a 0 at the end. So here's an example where they moved 80 into DL. When they shift to the right by 1, it gives us 40. Shifting right by 2 is going to give us 10. if I have 40. So let's do an example. So let's do 10. So if I want the decimal 10 in binary, I need 8 plus 2. 8 plus 2 is 10. All the rest of my bits are going to be 0. All right, it's an easy way to do that. 0, 0, 0. I'm going to shift right. So I have 10 now. I'm going to shift right by 1. So I should have, when I shift right by 1, I should get a 5. So I'm shifting right. So my carry flag over here will be 0. Bit 0 will be 1. Bit 1 will be 0. So I'm just shifting. And then all these are all zeros. 0, 0, 0. So I add this bit is worth 4. I say this bit, you don't know what I'm pointing to. This bit is 4 right here. It's worth 4. And this bit is worth 1. So you add the 4 plus the 1, right? 4 plus 1, and you get 5. So our new number, by shifting to the right, is a 5, and it divides by 2. All right, so we have the next two instructions are shift arithmetic left and shift arithmetic right. Shift arithmetic left is going to work exactly like SHL. So remember, you shift to the left, so the lowest bit is going to be filled with 0, and the most significant bit is going to be the control flag if you shift 1 to the left. So SHL and SAL are the same, are going to work the same. SAR is going to be a little bit different. SAR is going to perform a right arithmetic shift on the destination operand. So we're going to move this bit here on the right, which is the least significant bit. We're going to move it to the control flag, and then we're going to copy this last bit. So what was bit 7, which is now bit 6, is going to be copied to the spot that opened up. So an arithmetic shift is going to preserve the number sign. So if we have -80 and we shift, if we have shift arithmetic right, it's going to give us a -40. So it's dividing, but it keeps the sign. And same with SAR DL2, we get a -10. So we're going to look at this instruction, at these instructions, and calculate what each one does. Now this is a little bit harder because we have hexadecimal numbers instead of binary. So you're going to have to convert first from hex to binary, do the shift, and then convert back to hex. Okay, so you can do a little practice. So the first thing we do is we move 6B into AL. So here's 6B. And so first let's convert 6B to binary. So remember, when you have a hex number, you're going to take that B and convert that to binary, and then convert 6 to binary. So A is 10, B is equal to 11. So to make an 11 with binary, I need an 8 plus a 2 plus a 1. 8 plus 2 is 10 plus 1 is 11. So 8, 4, 2, 1. So this bit is worth 1. This bit is worth 2. This one is worth 4, but we're not using that 4. This bit is worth 8. So you have 8 plus 2 plus 1 is 11. And then to make 6, you just need a 4 and a 2. So it'd be 0, 1, 1, 0. This is worth 1. This is worth 2, 4. 4 plus 2 is 6. Okay, so this is the binary number and of 6b. And then now we're going to do a shift right by 1. So I'm going to shift this way. My control flag is set to 1. So I'll just do that. Control flag is 1. And then I'm going to add a 0 at the end. So my new number is 0, 0, 1, 1. I'm going to divide. I'm going to do 4 bits and then 4 bits. And then 0, 1, 0, 1. So then I'm going to convert this binary number to hex. This right-hand side is 1 plus 4. So this is a 5 here. And then this one is 1 plus 2. So this is 3. So this is 35 hex. So at this point, we have 35 hex. Okay. So now that we have 35 hex, we're going to shift to the left. So we have it right here, 35 hex. We're going to shift this to the left 3 by 3 bits. So we're going in this direction. And it's 3 bits. So we're moving out these 3 right here. So the control flag gets set to 0. We no longer have these bits. And we're going to add 3 bits to this side over here. 1 to the right, 2, 3. So our new number, I'm going to erase this. Our new value is 1, 0, 1, 0, 0, 1. And then, wait, sorry, that's wrong. 1, 0, I forgot this one here. 1, 0, and then 1,000. Okay, so 1, 0, 0, 0 is an 8. Because remember, this is worth 1, 2, 4, 8. 1, 2, 4, 8. So this is a 10. So it's A8. A8 is now, this instruction here gives you A8 in hex. It's gonna take a while, guys. Okay, next they move 8C hexadecimal into AL. So let's erase all this stuff here on the right. Go bye-bye. We'll keep these values that we found out. Okay. So we have 8C. Lots of practice here, converting to binary and to hex. So A, B, C 10, 11, 12. This is 12. To make it 12, I need an 8 and a 2. So it would be 1, 0, 1, 0. No, at 8 and a 4. 8 and a 2. Can't add. 8 and 2 is 10. So 8 and 4 makes 12. So 1, 1, 0, 0. And then to make an 8, I just need a 1, 0, 0, 0. Hopefully this all makes sense. And then I'm gonna, okay, so I'm doing an arithmetic right shift by 1. So what this is gonna do is we're gonna go to the right 1. Our carry flag is still gonna be a 0, right? CF is 0. Shoot. And then what fills in back here in the back is that open space is going to be a copy of the last bit. So the last bit is a 1. Let me make this a little more clear. This is a 1 and a 0. So the last bit is the 1, so we're going to copy that 1 and we're going to add it to the back. So our number is 1. Our binary number is 1, 1, 0, 0, 0, 1, 1, 0. So this number here is 2 plus 4 is 6. And then this here is 8. This is 12, right? And we said that 12 is a C. So this is C6 hexadecimal. Then we take this 6C hexadecimal and we're going to shift right again, but this time by 3. So when we do that, let me just show you, make sure you understand this part. So this is 6C right here. 1, 1, 0. Just going to copy it over. 0, 1, 1, 0. So when we shift to the right 3, we're shifting these 3 to the right. This is the control flag, right? The very first, the least significant bit. What we copy here, what we add to the end, to these 3 bits that are now empty, is a copy of the last one. So we're going to copy it 3 times. 1, 2, 3. So now what we have is, we know that 1, 1, 1, 1 is F. Why? Because 8 plus 4 is 12. Plus 2 is 14, plus 1 is 15. And that's F. A, B, you can see it on the screen. A, B, C, D, E, F, 10, 11, 12, 13, 14, 15. Okay. So that's F. And then this side over here, you have 1, 0, 0, 0, 0. Which is just 8. So this shift gave us F8, H. And there's the answers right there. It's exactly what we got. Yay. And I was looking at it to make sure that I was getting the right answer, because I could make mistakes doing these bit shifts and stuff. So you need to know just how the shifts work. So remember, SHR, shifting right, shifting left, SHL. You're going to shift however numbers, and then whatever bits are open, just fill them up with zeros. But the arithmetic one, shifting to the right, at SAR, the bits that are open, you copy the most significant bit into those. The SAL is just going to work like SHL. Okay, the next instruction is rotate to the left instruction. Rotate shifts each bit to the left. The highest bit is copied into the carry flag, just like normal. And all the bits that are moved out are copied to the lowest bits. So if I shift these two bits here to the left, then I'm going to take these two bits and I'm going to go over here and copy them on the back. So we never lose any bits. So whatever I shift out, I copy to the back. Same thing shifting to the right. Here's an example. We have this binary number. We're going to rotate this binary number 1 to the left. So the 1 it's a carry flag, gets moved out. And then we take that 1 and we just copy it to the back. So our new number is 1110001. So we just took this 1 on the left and copied it to the back. And that 1 also became our carry flag. Here they did it with the hexadecimal number. You can try this on your own. But notice that when you do a roll, all it's doing is super simple. I mean, you could definitely change it to binary and then back to hex to test it out, but it just flips your value. So it moves the 3 to the front. And here we did a roll of 4. So rotating to the right, same thing. This least significant bit 0, it becomes the carry flag if we shift by 1, and then whatever this bit is here in the lowest least significant bit then gets copied to the back. If we move 2 bits out, those 2 bits get copied to the back. If we move 3 bits out, 3 bits, they get copied to the back. So that's how the previous one, we copied 4. So remember, 4 makes that, so if you have a hex number, I think we had 3F. So 3 is 4 bits, F is 4 bits. If you roll over 4, then you're just flipping the numbers. Here's the same thing. So remember, 3 is 4 bits, F is 4 bits. So if you roll to the right, 4, you're just taking that 3 and switching it with the F. In this example, they're rolled to the right by 1. And so we move out this 1, we move the 0, and then we take that 0 and we copy it to the back, the space that got opened up, the bit that got opened up. If I were to roll to the right 3, let's say, then I would roll these 3 to the right, 0 would be my CF, and these 3 bits on the right hand side would get copied to the back, which are all zeros. So let's take a look at this example. We're going to convert 68 to binary. You can pause and do this on your own and then take a look at the solution. I'm going to go pretty fast in conversion here, as fast as I can possibly do it while writing. So 6 in a binary number is 0, 1, 1, 0, and then 8 is just 1, 0, 0, 0. We're gonna roll to the right or rotate to the right. So this 0 is my control flag. I'm going to take that 0 and I'm going to copy to the end here. So this is the new number in AL. And I'm going to take this number and I'm going to roll 3 to the right. So let me just rewrite it. I feel better if I rewrite it. Okay, so I'm going to shift these 3 to the right, and I'm going to copy them to the end here, the open space, the open bits. And my control flag is set to 0 because that's the least, that's the one that, oh no, I'm sorry, I'm rotating to the left, sorry. Let's redo this. So that doesn't happen. Okay, so I'm going to rotate to the left, not the right, because it's ROL. Okay, so 3 to the left, same thing, 3 to the left. And I'm going to put those here at the end. 0, those 3 bits, 0, 1, and then this most significant bit will be my control flag. So my new number is 1, 0, 1, 0, 0, 0, 0, and 1. And when I change that, hopefully I did that right. Let me check. Oh, so I did 6. Oh, I thought that, oh gosh. Okay, I did 8 here instead of B. I need new glasses. I thought that was an 8. Okay. So, okay, this answer works if this is an 8, guys. If it's a B, this is what you should get. You should get, just because I have the answer in the notes section, and just try it on your own with a B instead of an 8. This will be B5, and this will be AD hex. Okay. Sorry about that. Apparently I can't see. All right, so this is the RCL instruction. The RCL instruction, it's a rotate carry left, shifts each bit to the left, copies the carry flag to the least significant bit, or copies the least significant bit to the carry flag, and then copies. So notice this, let me grab the pointer, this least significant bit here comes from the carry flag, and the carry flag comes from the leftmost bit, which is the most significant bit. So let's say this bit in this position is 0, the 0 gets copied over there, and that 0 gets copied over here too. If this is a 1, control flag is 1, and the back gets a 1 also. That's the RCL. So here's an example. Go ahead and you could pause this and work it out and see how it works. But I think you are, you get what's going on now. And I can just go on a little bit faster. But I do want you to stop and try these, okay? Even though I'm going faster. So RCR, rotate carry right, same thing. We're going to go to the right. So if this right bit here is a 1, the 1 gets moved to the carry flag, and that 1 also gets moved to the back, to the bit that opened up. So rotate, so you're rotating to the right, and you're taking, just think of carry right. So whatever you put into the carry flag, carry it to the back. Okay? That's how you can remember this one. Here's an example that I want you to try out also. So pause the video, try it out. Here's the answer. again using 6B, not 6-8. Okay, this is a shift left destination. So this instruction has 3 operands right here at the bottom. You can have a register, and an immediate value like a number 5, 2, 1, or the CL register, or you can have a memory location, which is a variable, a register, and immediate number or the CL register. So we're going to have destination, source, and count. Shift left destination, what it does is, let's say you shift to the left 4 bits. Whatever you have in source, those 4 most significant bits in the source are going to get moved into the destination. So let's look at that, how that works. So here is our destination. Here's our source. So we moved this binary number into AL. We moved this binary number into BL. So we're shifting to the left. So 1 goes to the carry flag. And then this 1 from the source, which is BL, gets copied here. If I shifted 2, then these first 2 in the source will get copied to the destination, to the AL register. Okay, let's look at this example. We're shifting a memory location, WV val, 4 bits to the left, and replace its lowest 4 bits with the high 4 bits of AX. So this is our source, AX, and when we do that, WVal is going to have a new value, and we're shifting 4 bits because there's a 4 here at the end. So remember that each hex number is 4 bits. The 9 is 4 bits, so that 9 gets moved or shifted to the left. So that's the first step. AX has AC36, so the most significant bit, or the highest bit, 4 bits of AX, which is A, get copied to the back. So this 9 got moved out, and we just had BAC, and then that A got copied to the back of the hex number. And so when we shifted to the left destination, then we got BA6A. Sorry, I have to look at my big screen because I really cannot see. Okay, so just remember that each one of these is 4 bits. So that makes it easier when we're shifting by 4 bits. And then we have the shift right destination operand. So shifts a destination operand a given number of bits to the right. A bit position opened up by the shift are filled by the least significant bits of the source operand. So same thing, just like the other one, except we're shifting to the right, and we're taking, so when you shift to the right, you have space on the left of the binary number, which is most significant bits, and you're going to take the least significant bits of the source and move in there. So it looks like this. Your source, which is this BL here, this is BL. There. Destination is AL. So you're just going to put, you're going to put source on the left this time. Source was on the right before. Now source is on the left. And then whatever gets shifted out of the destination gets filled up by the source. So if you shift to the right 1, you take 1 from here. If you shift to the right 2, you take 2 from here and move them into the destination. And then the carry flag will be the very first thing that gets shifted out of the destination. So here's another example. We're shifting 4 bits to the right. So this 4, it's gone. And then we're going to take, dx is wrong. Okay, here we go. So AX is your destination, and dx is your source. So this one gets shifted out, so that goes away. And then this 4 gets moved here, ending up with 4234x. So here's another one for you to try on your own. Pause the video, try it, and here's what you should get using shift left destination, shift right destination. We're shifting by 4 and 8, so remember each one of these is 4 bits. Okay, so that's the end of this presentation. In the next presentation, I'm going to cover some applications of using these instructions. So we have all these instructions, now how can we actually use them in our programs? Okay? Please let me know if you have any questions, just send me an email. And remember, you've got to practice so that you can know how to use these, okay? So practice a lot on paper. There's lots of good review questions in your book at the end of each section, so do those review questions because that will be helpful. Okay, thank you.